This sequence will continue our treatment of the operational amplifier and all the cool circuits we can build with it. In today's sequence, we will look at a different connection of the op-amp. Okay, so far we've looked at negative feedback, where you feedback a portion of the output to the negative input of the op-amp. Today we will see what happens when we feed a portion of the output to the positive input of the operational amplifier. Okay, some really fun things are going to happen. All right. Before we start, I really wanted to touch on some of the things that we've covered in this course and how they relate to the sequence of material that I promised that I would show you in the very beginning of the course. Okay, so let's take quick stock of where we are and then move on to what the topic is for today, operational amplifiers. So at the very beginning of this course, we had talked about EECS, starting off with experiments as observed in nature. And I said, you could have tables and tables of numbers. You could have currents and voltages, and you could take a whole bunch of measurements and you could design your systems based on those measurements. But I said that was really hard to do, where the systems would be things like your iPad or video games and all of that stuff. So we said what we were going to do was abstract out all of this measured data and observations of nature, what nature really was, into the laws of physics or abstractions, such as Maxwell's equations. Then we said we would take these abstractions and build. It was still too hard to build systems with Maxwell's equations. We said we would make a set of assumptions that we called the lumped circuit abstraction. Okay, and those assumptions would relate to simplifications of Maxwell's equations, and that would give rise to the lumped circuit abstraction, and we did that. And as part of that, we got into the EECS playground. Okay, so this is where our EECS playground began. Okay, so we got into our EECS playground and we had a whole bunch of lumped elements. Okay, we had resistors and capacitors and voltage sources and MOSFETs and inductors, and you've seen all of these things now. Okay, we are pretty much at the end of the course, and so you've seen most of these things in this course already. Then we said building circuits, okay, filters and so on from primitive devices like resistors and capacitors and stuff was still too hard. So we said, hey, let's build the amplifier abstraction. Okay, so we built, I showed you the single terminal amplifier abstraction. From there, we took two paths. One path went down the analog domain, where in the last couple of weeks of learning, we've looked at the operational amplifier abstraction. Okay, this is a amplifier with a pair of inputs, a plus minus set of inputs, and an output taken with respect to ground. We proceeded down this path, and down this path, we looked at filters most recently. Okay, we saw how we could take the operational amplifier and generalize the concept of resistances, and much like you connected Rs to the op-amp, we could connect capacitors and inductors and view it from an impedance standpoint and build filters using the operational amplifier. And then at the beginning of this course, I said from there you could build all kinds of interesting systems using the operational amplifier. And in today's sequence, we are going to look at how to build the oscillator. Okay, so until now we have looked at, we've come to this point so far in this course. Okay, so far. So today we are going to do the last few pieces, and today we will look at the oscillator today. Okay, so we're pretty much at the end of our sequence here, at the end of the course here. Oh, by the way, you've also seen the basics of power supplies and so on in one of the homeworks that you have seen. Okay. We took a second path through the course where the simple amplifier abstraction was used in the digital abstraction. We built various digital gates, and from there we came up with a combinational logic abstraction. Okay, so we have multiple inputs and we had combinational functions. That's where we stopped. Okay, this is where you had come to. Okay, today we will look at the clocked digital abstraction. Okay, we'll just introduce that today, and that will be the end of it in 6002X. Okay, so we'll look at the clock digital abstraction today, and we will look at oscillators today. Okay, these two things. And from there, I told you in the beginning of this class that you could build instruction set abstractions, programming language abstractions, so on and so forth. And all of these you will learn in future courses. Okay, so this is kind of the lay of the land. And using all of those things, these components from a variety of courses, you can build really, really cool systems. But in today's lecture, we will look at the clocked digital abstraction, and we will look at oscillators and how the two are connected. Before we move further, I wanted to get back to operational amplifiers and show how we can build oscillators and then how that relates to the clocked digital abstraction. These other pieces of content, like the instruction set abstraction, the programming languages, and so on, you can learn in future courses that will be offered on MITx, and I look forward to seeing you there as well in future semesters. Okay, these courses will be things like 6004X, which relates to digital logic design and building computers. 6846 is about 6846X rather is about parallel computing. 600, which is likely to be offered very quickly, is about basic programming using Python and so on. Okay, there are other courses that you will see as well, such as 6033X, which has to do with building systems. Okay, there'll be many other courses such as 6455X, 6172X, 6173X that relate to building various aspects of systems, and I look forward to seeing you there for each of these courses.